My guests today are Jim Westdorp. He's the Chief Technologist at Ciena Government Solutions, and Lamont Copeland. He's the Senior Director for Federal Solutions Architecture at Verizon Business Group. Gentlemen, good to have you both with us. And our topic is post-quantum cryptography in the context of network operations and general cybersecurity. And I guess we'll start with Verizon, with you, Lamont. Just what does the picture look like with respect to protecting networked assets? And what should agencies be doing now to prepare for this post-quantum era, that some pieces of which are already with us?
Yes. Now, a lot of what we're seeing and what we're trying to do, work with the government and others that we work inside of industry today, is trying to understand how we're going to consume these encryption mechanisms, how we're going to start doing the security and doing the zero trust aspects. And this is a portion of what that zero trust would be, is the quantum encryption and how do we protect these networks today. So a lot of what we're seeing now is the inventory, the work to be able to understand how do I then know what my environment is, know what my technology is, know what my encryption mechanisms are, so that I can then start consuming and then bringing in this encryption today on a day-to-day basis. So once we know that, then it's working with our partners like Ciena to be able to say, okay, what are these standards and how do we take these and consume these into our capabilities, into our environments, into our technology, so that then we can then work together hand in hand to be able to deliver this out, to deliver specific outcomes to our government customers and protect their networks and the data in the nation today.
Right, Jim. So the implication here is that encryption is not simply done to data in a database in a data center, but it exists throughout the network in devices, APIs, and communications protocols.
Yep.
And tell us more.
Yeah, absolutely. There's data at rest, and there's encryption that has to be done on that. But you really have to look holistically at your data and where it exists, where it's transferred between, and whether it's at rest, whether it's in flight. There are different protection mechanisms for each. On the network side, we tend to focus more on the data in flight aspects of it, but you really have to look at the whole problem. And from a network perspective, we're looking at how do you encrypt the data, of course, but how do you encrypt it in such a way that it makes the problem of your adversary, who potentially is trying to break that crypto or to intercept that data, how do you make that problem difficult to the point where it doesn't make practical sense for them to try to break the crypto or otherwise corrupt your network? And so when you ask about some of the implications of quantum crypto and crypto algorithms, that's really what it means. There are a new set of algorithms now that we have to support as industry, and we're integrating those into our hardware. As Lamont was saying, there's still going to be an evolution from where we are today and where we need to get to in terms of implementing all these post-quantum crypto algorithms. But we're now that we have a set of standards, we're at the beginning point of that journey, but we do have a point to aim for. And as industry, we're busy implementing those and then working with our partners like Verizon on how we roll those out and make them available.
Right, and I think it's important to understand that the crypto algorithms, wherever they reside throughout your network, are not a fixed thing for all eternity. We've had successive generations of algorithms. So that gets to the notion, and maybe Lamont, you can discuss this a little bit more, is the idea of staying agile on your feet as this evolves and as cryptography changes.
Yes, because the crypto, as you saw, we have our first three that came out with the FIPS 203, 204, and 205, which are dealing with the encryption and the digital signatures. That's just the start of where the environment's going to be. There's going to be more which is going to be put into our networks to be able to then protect the user and the data itself. And a lot of that's going to be then evolving over time. Like we're going through right now a phase where there's a lot of upgrades and things that are happening across the network, the government networks today. We're trying to move from TDM networks into the, what would be capabilities which will help support all the new applications like AI. So how do I then pull in fiber assets and making sure that I'm pulling my fiber network and providing that same encryption and be able to be agile to be able to support that there? How do I pull that into a wireless network too as well? We're talking about a nation which is very mobile. We're not just looking at how do we go and do my TikTok at the Panera Cafe, but how do I now do conversations and work on government and work on policy and build those things in a mobile aspect, and how do I make sure I'm still protecting those when I'm doing that? or building out private networks and making sure that I'm able to work in a wireless bubble to be able to say, hey, here's how my technology, the robotics, the other capabilities can work inside of there in a protected manner using this encryption. And then if I'm building also tying all these things together with overlay networks, which have to be able to say, okay, I'm working both over a private network or over a public network too as well. I'm having to be able to pull this encryption in to make sure that these are all working together. All these things have to look in an ecosystem and how they work together to be able to deliver that secure communications back and forth. And a lot of that is going to be, just as our networks and as our data is agile, our encryption and our security mechanisms have to be agile too as well to be able to thwart any type of threat today.
Right, and encryption itself is a computing demand. And that's part of the reason why algorithms get replaced over time as they get big, and can we get to the same encryption safety with a smaller footprint? And so maybe discuss the performance implications and how you can find out before loading it onto a critical network and I've got some real degradation going.
Yeah, so the history of the various crypto algorithms has been one of, there's usually a trade between the overall security of the algorithm and the overhead associated with that algorithm. And so you can have more security, but if it adds enough overhead or enough latency to your network so that it makes the network less useful, that's not a good thing. So there's always this push and pull in terms of the trade space. And as we look forward, what we're doing on the equipment side of things is we're loading in extra compute, extra memory, things that will allow us to absorb new algorithms as they're defined and be able to implement them in such a way that it's relatively transparent to the user. In fact, many of the encryption algorithms and mechanisms that we use today are designed to be transparent to the user, what we call a bump on the wire, meaning it adds such a small impact to the overall network that an end user isn't going to be able to detect it. Because in fact, if they were able to detect it, if we added substantial latency or jitter to the network, that would make some applications like video or real-time controls less effective. So we really want to take that into account and avoid that if at all possible. Just going back to the agility theme, really the key is to make sure that we have the ability to evolve and change the algorithms and the capabilities of the network over time. And that's what we're busy doing.
I imagine Verizon is kind of a model of how that should work, because you do have a gigantic network to maintain and keep at peak performance, and yet as you inject new technology, how is it done? You don't do it right on the main network and all of a sudden 10 million users feel it. You must have a methodology that would be useful for anyone that's looking for these updates.
Yes, no, we have rigorous testing practices, which both some are industry and some are our own homegrown things that we make sure, because anything that goes on our network, we realize how critical it is for our end users, the enterprises, the government that uses these. We understand how critical that network is, and having that always up communication path to be able to support whatever that end outcome that you're trying to do for your business or the government itself today. So we're going and using and doing a lot of testing both on the wireline and the wireless networks and on the devices too as well, because don't forget, this is an ecosystem. It's not just the network itself, because the network doesn't work without devices, without applications, all these things that have to run together and how they all are interacting from a performance standpoint, from a security standpoint. And we test those in secure environments, closed environments, which mimic what our network looks like today. So yes, there's some very rigorous standards, and we're always looking to be the best at what we do, and necessarily not always the first out there, but we're also going to make sure that when we deliver that service, it's the service that the nation can rely on.
And Jim, often when we think in the cybersecurity context, people think of data being purloined, off of a network, yep, or something implanted via a phishing attack. But there's also the issue, and you don't hear as much about this, as simple surveillance by listening in.
Yep.
And this can happen not just necessarily at the endpoints, which gets to the idea of security of network, of data when it's on the network, and communications when they're en route.
Yeah, one of the classic problem of cryptography is trying to make sure that if there's a man in the middle somewhere, if there's somebody listening to a conversation, the data itself is encrypted in such a way that even if it's intercepted, the task of decrypting it is impossible, or at least so hard that there's no practical way to get at the data. And that's what's happening today with the post-quantum crypto algorithms. We have a threat in the form of a future capability of a quantum computer that could come in, and if somebody were to intercept the data, it's powerful enough to potentially break that. And so that's driven a need for new algorithms that are more robust, more complicated, and thus even a quantum computer, even if they were there listening in, can't easily break that algorithm. And so it's really the threat of quantum computers that has driven a set of changes and a set of new algorithms. Now, man in the middle is the classic problem, and you want to be able to prevent them from intercepting and decrypting the data. But there are also quantum techniques and capabilities that we're looking at, still researchy, where even if the guy is, or your adversary is a man in the middle, you can detect the fact that he's listening to you. And that's another way of increasing security. So you want to make sure that anybody who is in the middle and listening to you has a very difficult, if not impossible, time of decrypting it. And the ultimate is to detect that he's there in the first place. And there's some quantum techniques for that that we're looking at as well.
Yeah, there's a word for that. I can't remember. Is the observation of a phenomenon changes it, and that's kind of the principle here.
That's a fundamental quantum principle, and I forget the quantum term as well. But there's an uncertainty principle which says that if you observe something, you change the act of observing it changes it, and that's the physical principle that's involved in detecting if somebody's
all right.
intercepted traffic.
So you want to nail down your photons. And I guess we should bring this around to the NIST release of these new standards, these new quantum resistant algorithms that are coming forth. And maybe let's wind up with your sense of the importance of this and what the government should be doing, not NIST, but the rest of the government in relation to the emergence of these.
Yes. No, a lot of it's going to be going down to the encryption and understanding that inventory of that, and how then you apply these in specific situations, looking at and understanding not just the inventory, but how does it work in association with your applications, what you're running across your network, how you're going to then encrypt and manage that accordingly with the performance that's necessary, because you're going to have to work through both non-real-time and real-time data, and how do these things impact that. And then talking about the digital signature side of house, how do we then protect, like, okay, I am the creator of this data, how do I know that I'm I'm signing this data, I'm using this across this along with the encryption, the quantum encryption, and securing it all the way end to end from that end user to end user, not just to the device or that database or that server. So a lot of it's going to be understanding what these standards are, how they apply to what your environment is, and how do you then look at the risk factors and understanding how it fits into there, and then making sure that you apply that accordingly so that the communications today would be seamless, that bump in the night that we would want. That's where we want it to be.
Right, you don't want to overlook that authentication piece, which is affected by this emergence also.
Correct.
Fair to say. Good.
Yeah.
Jim?
Yeah, what we're looking at is a fairly long-term transition, something of the order of 5 to 10 years to go from ubiquitous public key infrastructure and cryptography, which is what we have today, to ubiquitous key infrastructure and crypto infrastructure that's based on the post-quantum crypto algorithms. So we are looking at a transition, and as part of that transition, users, be that in the government or commercial enterprise that are using the networks or that have assets that need to be protected, in transit or in storage, what you need to do is you have to actually look at the information that you want to protect and consider what the viability is of that data and how important it is. If it's important to be secured over a long period of time, nation state secret kind of stuff, or potentially maybe patents or special information that's important to the corporation, you want to protect that over a long period of time. The information or the systems that store and transmit that information need to get transitioned to these new algorithms sooner. And information that's more transient, well, maybe you don't need to worry about that right now. But there's a whole transition and planning process that has to we have to go through as an industry, and we're ready to help with that.
Jim Westorp of Ciena, Lamont Copeland of Verizon, great having you with us.
Thank you.
Thanks, Tom.
And you're listening to federalnewsnetwork.com.